Welcome to the Hillsville Library. You can see we've got lots of decorations happening today. So we're celebrating Christmas in July here. Today we're going to do some edible experiments and just have some tasty treats. Before we start, I'd just like to acknowledge the traditional owners of the land, the Wurundjeri people, and pay my respect to their elders past, present and emerging. Before we start our science today, because we're working with food, we need to make sure that we've washed our hands with soap and water. Okay, so we're gonna do a really easy experiment with some tasty marshmallows. All you need for this, some marshmallows and a microwave. So we're going to start out with one marshmallow here. I've got a pink one so that we can see nice and clearly what happens to this. We're going to pop this in the microwave for 20 seconds and we're going to see what happens. Before we start, see if you can have a guess. What do you think will happen? Will our marshmallow melt down and ooze all over our plate? Or will something different happen? What do you think? Will it go all brown and burnt? Let's find out. Okay, so if you were watching your marshmallow in the microwave, you should have seen it puff up a bit and grow and expand some. And now that we've taken it out, you can see it's melted all back down and gone all soft and sticky and a bit stretchy. Stretch that out. And of course, stick it to my fingers. Delicious. So what do you think will happen if we put two marshmallows onto one plate? All this stickiness on me. Let's do a pink one and a white one. We put them nice and close together, put them both in the microwave. Let's find out what's gonna happen. Okay, we're gonna put it on for a little bit longer this time, seeing as we've got a bit more to heat up. Got 25 seconds on our microwave. Pop our marshmallows in. And let's see what happens. Our marshmallows both puffed up, smushed together, and look, we've got an almost perfect line here in between our two marshmallows, but they are well and melted together. Our two marshmallows have turned into one. Now, seeing as we're celebrating Christmas in July, and for just a bit of fun, we thought we might try making a marshmallow snowman. So we've got some toothpicks here. All we're gonna do is stick some marshmallows onto our toothpick. And then we're gonna pop our little snowman. You might actually like to give him some arms. We've got some toothpicks here. I'll stick some arms in. Here we go. You can decorate him more if you like. Put a little face on, anything you like. Maybe a little hat for your snowman. But let's find out what happens when our snowman goes in the microwave. Okay, so we've got our timer on 25 seconds again. Got our little snowman, marshmallow snowman, ready to go in the microwave. Let's pop that in there. Oopsie, it's fallen over. Stand them right up. Okay, here we go. Oh, he's fallen over. Look at our marshmallow man. He's gone a bit smushy, all drooped together. You can see all our marshmallows sticking all together. They're very sticky and very tasty. I really hope you'll try this one at home. It's super easy, lots of fun, and you'll get a better view of just what happens in the microwave there as everything puffs up. So let's quickly talk about the science and why our marshmallows puff up so much in the microwave. Now, our marshmallows are made mostly of sugar, a bit of water, and lots of air bubbles. So what happens in our microwave is when our air bubble heats up, our gas actually expands. Our sugar softens and allows everything to expand and rise up and move out. And our water actually also expands, and some of it will evaporate a little bit as well. So as soon as it comes out of the microwave, some of that water that's gone and our air cools down, everything smushes all back down and droops all back down. And that's why we get this lovely, sticky, stringy mess. Okay, so we're doing some edible experiments today, but we're also going to make ourselves a nice drink to have with our tasty treats. So we're going to make some fizzy lemonade. We've got some lemons here, so we need to juice a few lemons. You might need a parent or guardian to give you a hand with cutting up your lemons. We've got a bit of a sharp knife there. I'll get rid of that seed. And we need to squeeze out as much juice as we can out of our lemons into our jug here. Give that a good squeeze. Okay, so we've squeezed some juice out of some lemons. We used about 3 lemons, but it's up to you. You might like to have it a bit stronger, a bit more lemon juice in there, or maybe a bit weaker and only use 2 lemons, however you want to do it. It's up to you. Now, lemon juice though on its own, does it taste very good? It's a bit sour, makes you pull a funny face. So we need to add some water into our lemon juice. Got about a cup of water here. We're going to pour a bit into there. Again, you might like it a bit stronger to have a bit less water in there, or maybe you like yours nice and weak and you can add a little bit extra water. However you want to do it, it's up to you. Now, what's the other thing we need for lemonade? If we're going to make fizzy lemonade, we need our fizz. So the way we're going to get that is with some bicarbonate soda. Bicarb soda, also known as baking soda, whatever you want to call it. So we're going to get about a teaspoon of bicarb soda out of here. Not too much. There we go, about a teaspoon. And let's see what happens when we add that to our lemon juice. Okay, so we got lots of bubbles there. That was a big reaction, but it was a good one. Let's give it a bit of a stir, and you can see we've still got a bit of fizz in our lemonade here. You can hear it fizz when you stir it around, but we might want to make it a bit tastier. So we're actually going to add some sugar in here as well to make it a bit sweeter. We'll pour some in there. Give that a stir around as well. It fizzes up a bit again. So give that a try. Like I said, it's up to you, however you like it. You might want to make it a bit sweeter, add a bit more sugar, or maybe you want it a bit more sour to add a bit more lemon. Or maybe it's a bit strong and you need some more water, but give it a try, give it a taste and see what you think. Okay, let's give it a try and see what it's like. I'm going to pour a little bit into my glass here. Oh, it's very fizzy. Okay, so let's talk about why this happens and how we get our fizz into our lemonade. So, our lemon juice was very sour, and what that tells us about our lemons is that it's quite acidic. So other foods that are quite acidic that also taste a bit sour are vinegar, limes, anything like that. It's kind of nice and easy sometimes to tell which of our foods are quite acidic. But what's harder to tell is when something's not acidic and it's at the other end and it's called a base. And that is what our bicarb soda is. It is a very basic. So when we mix the two together, they cause quite a reaction and it actually releases carbon dioxide, and that's what makes our bubbles. So when we have an acid and a base mixing together, they create a reaction, mix together and make carbon dioxide, and we get our bubbles. But when we added our water to our lemon juice, we didn't get any reaction, and that's because our water is very neutral. So it's not very acidic and it's not really a base, it's just right in the middle, so we don't get any reaction. Okay, we're gonna do another super easy experiment with something a bit healthier this time. We're gonna use some fruit, particularly an orange. And all we wanna know is our orange going to float or sink? So we've got a big jug of water here. Let's find out. Before we start, let's have a guess. Do you think our orange is gonna float, or do you think it's going to sink? Let's have a look. We're gonna pop it in the water. So our orange is floating. Can you see it bobbing right at the top of the jar there? All right, let's take that out. And now I'm gonna peel our orange. Okay, so we've taken the peel off our orange. It's still whole, but it's got no more peel in it, so it's a little bit lighter now. So what do you think now that if we put it back into our jug here, do you think now that it's got no peel and it's a little lighter, will it float or will it sink? Let's find out. Can you see it? It's dropped down to the bottom there. So it actually, now that it's got its skin off, is sinking. Now why would that happen? You think if we made it lighter it would float, wouldn't you? But what actually happens, you can see on our orange skin here, it's got lots and lots of tiny, tiny little holes that we call pores. Just like you've got all over your face, you've got tiny, tiny little holes that you can't even see. Our orange has got that. So it actually traps air inside these little porous holes all over it and makes it actually more buoyant and makes it a bit more able to float. It's got more air trapped in there, so it floats a bit easier. Whereas once we take all this skin off, it actually makes our orange denser, which means that it has got less air in it and sinks down to the bottom instead of floating. Okay, so now we're going to make something very tasty. We're going to make some ice cream, and we're going to do it in about 5 minutes. So super quick ice cream. So what we need, we've got some cream here. This is going to turn into our ice cream, and we've got some Snap Lock bags. So we've got a smaller one and a bigger one. In our smaller one, we're going to pour some cream into there. Get that off there. There we go, pour that in. Lovely, so we've got some cream in there. Now you might like to add some tasty things to your ice cream as well. We've got a bit of vanilla essence, so I'm going to put a couple of drops of that into our bag as well. It's going to be very vanilla-y. And we're going to add some Nesquik too, because I think that will be quite tasty in our ice cream. I'm going to scoop of that out and pop that in there too. And we're going to give that a bit of a shake around, mix it all together. Yummy. All right, and we're going to seal that bag up nice and tight. All right, we'll put that bag aside for a moment, our little creamy bag. And then in our bigger Snap Lock bag here, we're going to fill this up with ice. So we've got a whole lot of ice blocks here. Get these ones. Alright, great. So we've got a whole bunch of ice in our big Snap Lock bag now. And we're going to take our smaller cream bag, make sure that's locked up nice and tight. Get a bit more of a mix there. Mix it all around. All right, we're going to pop that in with our ice. Put that right in there. Now, what we're also going to add to our big bag is some salt. So, open this bag up here, we're gonna do about half a cup of salt. So I've got a quarter of a cup here. We're gonna put one of those in and another one. So now we've got half a bag of salt in there. We're going to slash this one up nice and quick, and then we're going to give that a shake. We're going to shake this around for quite a few minutes, about 4 or 5 minutes, keeping an eye on our small bag in there and how that's going. Let's give that a good shake. We might need a tea towel over that because it gets very cold. So protect your hands. You might like to use a tea towel or some gloves or something. It's so cold. Let's have a quick look at this. I'm going to bring this little bag out. Oh, it's not too bad. It's getting there. It's still pretty soft. Let's try it a little bit longer. So you can see it's still quite soft in here, but when we open our bag up, look at this. It's sticking to our bag and it's gone quite hard and quite icy, just like ice cream. Let's see if we can get this off here. Show you some of this on our plate. Here we go. You might like to eat it straight out of the bag, I reckon. But you can see here, our cream has gone hard, it's gone icy. Let's have a quick taste. And it's turned into some yummy, creamy ice cream. Okay, so what happened here? How did we manage to get our cream to turn into frozen ice cream so quickly? So what you'll find that if you try this experiment without adding any salt into our big bag here, it actually won't work for you. So our cream will stay sloshy and liquidy and won't turn into ice cream. So what we do by adding the salt to our ice is we actually lower the ice's freezing temperature. So normally water freezes when it gets to 0 degrees Celsius, but if we have salt in there, then it actually is a lower temperature that it has to get to before it will freeze. So if you had some fresh water and some salt water and put them both in the freezer, which one do you think would freeze first? Have a think about that one. So what happens is when we add the salt into our ice tries really hard to really quickly turn back into a liquid. And what it needs to turn that back into a liquid is heat. So it actually is sucking up the heat from around it, outside the area, and also what's closest to it, which is our other bag, our cream in here. So it's quickly sucking up all that heat, trying really quickly to get back into a liquid and taking all the heat out of our cream. So even though our cream was cold and came out of the fridge, compared to the ice, it's warmer. So it's got a bit more heat than our ice does. So it's taken all the heat out of there, sucked that all up, and turned our cream into ice cream.